All right, review for the Chapter 7 test. Says, for 1 through 3, state the most specific name for each figure. Be sure you know you answer according to the values and markings, not just by looks. So when it says most specific name, they're all quadrilaterals, all right? But we're hoping for a more specific name based on what information we're given. Remember when we have arrows like this, that means those two sides are parallel. When we have arrows here, that means those two sides are parallel. Okay? We know nothing about the angles. All right? All we know is that the opposite sides are parallel, so we're going to call that a parallelogram. All right? Now, number 2, we don't know anything about parallel, but here we have opposite sides equal, not the same all around, but the opposite sides are, and we have 4 90-degree angles. That makes this a rectangle. And on this one, we have all 4 sides being the same and 4 right angles, meaning this is a square. All right, 4 through 6, write in the measure of each angle, okay? Well, with a parallelogram, okay, and it says these figures are parallelograms, so we know that, we're not assuming. We know that opposite angles are equal. That means this must be 55 degrees. We also know that consecutive angles are supplementary, which means G and H are supplementary. H and E are supplementary. E and F are supplementary. And think about it. Remember, we have 2 obtuse angles and 2 acute angles. The 2 acutes are the same, the 2 obtuse are the same. But they add up to 180. So if we do 180 minus 55, we end up with 125 degrees here and 125 degrees here. Right? Same concept on this next one. On number 5. This is an acute angle. This is an obtuse angle. They're not equal to each other. We will not say they are equal, but we know that they add up to 180 because consecutive angles, consecutive meaning the next angle, if you were walking around this track, that's the next corner. Consecutive angles are supplementary. So we have 10x plus 80 equals 180 degrees. We're going to join like terms here. Then we're going to subtract 80 and get 100. And we divide by 10, we get x is 10. But remember, pay attention to the directions. On this one, it doesn't say find all the angles. It says just find the value of x. All right? Now, if we wanted to, just for practice, if we know this one's 70, we know this one's 70. And if we plug in a 10 right here, 10 times 10 is 100, plus 10 is 110. Another way of doing that would have been 180 minus 70. Okay? And that's actually a shortcut. We talked about this in class. Since we know this is 70, we could have figured out this was 110, and we could have just done 10x plus 10 equals 110. And then we could have done 10x equals 100 and gotten x equals 10. So there are 2 ways of doing this. Whatever you're most comfortable with, you go with that. All right, write an equation to find the value of x. All right, well, opposite angles are equal, so that means this is 49 also. But we know -1 plus 10x equals that 49. Because -1 plus 10x is the expression for that angle. So if we add 1, we get 10x equals 50. And then when we divide by 10, we get x is 5. And if we plug it in just to check, 5 times 10 is 50, minus 1 is 49. All right, number 7. Write the measures of the angles in the figure. Okay. So, remember, when we have a shape like this is a rectangle, 4 90-degree angles. Basically, we end up with 4 little triangles inside, okay? And, if you look at this triangle right here, all of these triangles are isosceles triangles, okay? So those two sides are the same, which means the base angles are the same. So if this is 34, so is this. And if we folded it over the middle line, that means this is also 34, and this is 34. Okay? Now, since each corner is a right angle, that means the missing angle at T is 90 minus 34, and that's 56. So if that's 56, so is this. And since the upper triangle is the same as this one, these are both 56. Now, there's a few different ways to find the ones in the middle. Every triangle adds up to 180. So if I take 34 doubled, that's 68. And if I do 180 minus 68, I get 112. So that means this right here is 112. And so is this. Now I have two options. To find the last missing angle in the middle, I could do 180 minus 112 because those lines are supplementary. They form a straight line and get 68. Or I could have added up 56 and 56, which is 112, and done 180 minus 112 and gotten 68. So that's how I get every angle in that rectangle. Okay. Now with this shape, all the sides are equal. Okay? So if you look on your chart, this is called a rhombus. And on a rhombus, the diagonals bisect the angles, which means if that's 53, this is 53. And so the opposite ones are the same also. So these are both 53. Now the other thing is, in a rhombus, the diagonals are perpendicular. So this is 90, that's 90, this is 90, and this is 90. And then you just do the math, find the missing angles. You add 90 plus 53. That's 143. And then you do 180 minus 143, and that gives you 37. So that means this angle is 37, this angle is 37, this one's 37, and this one is 37. And that's how you break it down. Write an equation to find the value of x and each angle measure. Well, this is an isosceles trapezoid. Remember, it's basically an isosceles triangle with the top cut off. So the base angles are the same, which means 22 minus 6 is equal to 60. 22x, sorry. So if I add 6 to both sides, I get 22x equals 66. x equals 3. Right? So A is clearly 60 because it has to be the same as D, which is given to us, so that's not too tough to get. All right? And then these two angles and these two angles are supplementary, so 180 minus 60 is 120. Okay? Easy enough. So again, we have the same thing, it's just upside down this time. An isosceles trapezoid. Like we said before, T and S are supplementary. So 55 plus 17 plus 12x equals 180. So I'm going to combine like terms. 12x plus 132 equals 180. Subtract 132, I get 12x equals 108. So x equals 9. So first we have to do is find x. Now we know t is 55. Therefore we know q is also 55. And we have two choices. We can do 180 minus 55, or we can just plug in 9 right here and get 125. And back to that shortcut again, we could have found out that this was 125 originally and just done 17 plus 12x equals 125. That would have given me 12x equals 108. And you can see that's the same thing as right here. Just saves a step. So if the shortcut's comfortable for you, do it. If not, don't worry about it. All right, last but not least, we're going to plot these points. So -7, +6. Right up here. -2, 8. Right there. 2, -2. And -3, -4. Do your best to draw straight lines. And there we go. Okay? Now we're going to label them A, B, C, D. Now we're going to find the measure of AB. It tells us right here what to do. So I'm going to go and I'm going to put my subtraction bar sign first. And I'm going to do 6 minus 8 and -7 minus, careful, it's a -2. So 6 minus 8 is -2. This becomes plus. So that is -5, right? And that means it's a positive 2/5. And think about it. If I wrote my name on this little hill, it's going uphill slightly, so that's a positive slope. AB should be positive. And therefore, you know CD should be positive also. Now, we don't know it's the same right yet, but we do know that this one should be positive. And BC, if I write my name on this one, it's going downhill. This should be negative and this should be negative. Think about these things ahead of time. All right? Now, BC. I'm going to do 8 minus -2. Again, it's not 8 minus 2, it's 8 minus -2. And then -2 minus +2. Right here is going to give me 8 plus 2 is 10. and negative 2 minus 2 is negative 4. That should also reduce. It says reduce your answers, so they're both even, so that's negative 5 over 2, or 5 over negative 2. It doesn't matter where the negative is. But the important thing is it's negative. And also notice 2/5 and negative 5/2 are opposite reciprocals. That's important. Now CD. Okay, so I'm going to do right here, y minus y. So I'm going to do negative 2 minus a negative 4. I write it in like that because it's going to become positive. And I'm going to do 2 minus negative 3. So on the top, 4 plus negative 2 is negative 2. Negative 2 plus 3, 2 plus 3 is 5. 4 minus 2 is positive 2. And this is 5. So I end up with 2/5, which is the same as right above it. Those are the same. That's a good sign. And then last but not least, I'm going to do dA. So I'm going to do negative 4 minus 6. And I'm going to do negative 3 minus a negative 7. That leads me to negative 10 over positive 4, which again reduces to negative 5 over 2, or 5 over negative 2. Notice that these are the same. Okay, so opposite sides have the same slope, so it's definitely a parallelogram, and consecutive angles have an opposite reciprocal. So AB and BC, are they perpendicular? Yes, they are. And we're going to abbreviate here, opposite reciprocal slopes. BC and CD. BC is here, CD is there. Are they perpendicular? The answer is yes. Again, opposite reciprocal slopes. So ABCD we know is a rectangle. And notice the instructions. It said prove it's a rectangle. They kind of told you it was. Consecutive sides are perpendicular. Or you could say consecutive angles are opposite reciprocal. And that's it. That's going to be your test.